Okay, so after we lost internet today and lost you, we did two examples in the first question on your homework sheet. So example 1 was a 10 kilogram box. The coefficient of friction was 0.3, and the force that you were pushing with was 84 newtons. And the question was, what is the acceleration? So your first step is always to draw in all the forces. So there'll be an Fg going down. There'll be an Fn going up. You're pushing with a force of 84 newtons one way, and friction is acting backward. Okay? So there are 3 steps we usually use. The first step is almost always sum of the forces in the y direction. The only time we wouldn't do sum of the forces in the y direction would be if there isn't any friction. Because if there's no friction, we don't care about Fn. Because the reason we do sum of the forces in the y direction is to get Fn, which will allow us to get friction. You'll notice I wrote some of the forces in the y direction while I was talking, and right away I canceled out the MAY. That's because this box that's sitting on this surface isn't moving in the y direction. So there's no acceleration, so AY is 0. So what are our forces in the y direction? There's Fn going up and Fg going down, and they're going to be equal to 0. Because they're going in opposite directions, one way has to be positive. Normally that would be up, so it'll be Fn minus Fg. So then Fn equals Fg, and we know from yesterday Fg equals mg. Now you could put your numbers in here, and we usually did in grade 11, but in grade 12 I'm going to encourage you to carry your letters because our questions are going to be bigger. So you could use this Fn. We know that friction is equal to mu Fn, which means friction is equal to mu mg, and again, you could find a value, and it wouldn't be wrong if you did. I'm just not going to. Instead, I'm going to carry my letters, and I'm going to go to sum of the forces in the x direction. So these are our 3 equations. 1, 2, 3. Okay? And in the x direction, there's a force that you're pushing with going one way, and friction going backward, and we usually call the direction of motion positive, so friction would be negative. And we're trying to find A. So divide both sides by m. So it'll be Ax equals F minus, and friction is really mu Fn. Whoops, I should have written mg there. And we're dividing by m. So really Ax is equal to F minus mu mg over m, and now we can fill our values in. F was 84 newtons minus the coefficient was 0.3 times 10 kilograms times 9.81 meters per second squared, and then divided by 10 kilograms. And when you punch this in your calculator, you should get 5.457 meters per second squared. Okay, so that was our first example, and Michael took a picture from it on the board. Example number 2 goes back to me saying that the static frictional force varies. So we had our 10 kilogram box again. So again, Fg would be acting down, and Fn would be acting up. And this time it's sitting at rest, and the static coefficient of friction is 0.4. And I'm pushing with a force of 20 newtons. And so my question to the class was, what would be the force of friction, static friction, acting backward on the box? So this time we're looking for the force of friction. So we're going to need the normal force, so sum of the forces in the y direction. And again, the box isn't moving in the y. So again, it's going to be Fn minus Fg equals 0. So again, Fn equals Fg equals mg. And now we go to friction, which is still mu Fn. Oops, that really is an n, the paper moved. Which then is mu mg. So we can fill our numbers in because we want it. What's the force of friction? So mu was 0.4, m was 10 kilograms, and g 9.81 meters per second squared. And when you do this, you get friction to be 39.24 newtons. So this is the static friction. But is it what's acting on this box right now? I'm pushing with 20 newtons. there's no way static friction is going to push back with 39.24, because if it does, this box is going to move in the opposite direction, and I'm going to look like the biggest loser ever, right? I'm standing here pushing on this box that was initially stationary, and I start to push and the box slides towards me. Static friction will never make an object move. That's what I meant by it'll vary up to a maximum value. If I push with 20 newtons, it's going to push back with 20 to stop me from moving it. If I push with 30, it's going to push back with 30. When I push with 35, it's going to push back with 35, etc., until I hit the max, in this case 39.24. As soon as I push with this much, static friction will try to oppose me, but the box will begin to move. And when that happens, it then switches to kinetic friction, and kinetic friction is always less, so it will continue to move, okay? And then we also did number 1 on this sheet. And number 1 on the sheet, again, is a box with a person pushing with a force of 50 newtons, and it says the box weighs 300 newtons. So that's the FG. Fn is acting up, friction is acting backward, and it says the coefficient is 0.1, and it wants to know what's the acceleration. So, just like the other two, we start with some of the forces in the y. It's not moving in the y. So Fn minus Fg again equals 0. So Fn equals Fg equals the 300 newtons that I was given. Then I go to some of the forces in the x direction. Equals max. So there's F minus friction is equal to max. But what's friction really? It's really mu Fn. And what am I trying to solve for? I'm trying to solve for A. So divide both sides by m again. So Ax will be equal to F minus mu Fn over m. So A will be equal to 50 newtons minus 0.1 times 300 newtons, which will be 30, divided by, I don't have m, but I can find it because I know Fg equals mg. So m is just going to equal Fg over g. So 300 newtons divided by 9.81 meters per second squared will give me my m. When I do that, it's 30.58 kilograms. So over here, 30.581 really kilograms. And on the top, it's going to be 20. And so I should get an acceleration of 654 meters per second squared. And then the second part of the question is kinematics, right? How far does the wagon move in 2 seconds if it starts from rest? So VI is 0. How far does it move is delta D in 2 seconds. Yeah, delta T. And I have my A. So delta D is equal to VI delta T plus 1/2 A delta T squared. This goes to 0. Delta D is equal to 1/2. That 0.654 meters per second squared times 2 seconds squared. 2 squared is 4. Half of 4 is 2. 0.654 times 2 should be 1.308 meters. Donezo. Okay, so what I had said in class was now go back and try all the others that caused you issues, and if you would do up to number 7 on the sheet for tonight. Okay? So 1 is done, so now do up to 7. All right, thanks.